Wi-Fi. It's kind of funny, right? It's this invisible force that basically powers our entire digital lives. But the moment it stops working, man, it is one of the most frustrating things on the planet. So today, we're going to pull back the curtain and demystify it. We're going to look at how these networks are really configured, starting with that little box in your living room and going all the way up to huge corporate systems. Let's get into it.
And let's be honest, most of the time, it really does feel like magic, this wireless freedom that we completely depend on. But, when that magic sputters out, a video call drops right in the middle of a sentence, or you get that dreaded buffering wheel, it's a harsh reminder that there's a whole lot of technology under the hood that needs to be set up just right.
So for this explainer, here's the game plan. First, we're going to decode your home router. Then we'll see how the pros manage Wi-Fi on a massive scale. And finally, I'm going to give you a super useful systematic method for troubleshooting when things inevitably go sideways.
All right, let's kick things off right where most of us deal with Wi-Fi every single day. That one little box, probably blinking away in a corner that you got from your internet provider. So that box is what we call an integrated router, and it is a serious multitasker. It's not just shooting out a Wi-Fi signal. Nope. It's also a switch for anything you plug in with a cable, and it's your gateway to the entire internet. It's basically the clever, all-in-one mission control for your whole home network. And while it's just sitting there, it is doing a ton of heavy lifting in the background. I mean, it's handling all your security, it's handing out unique IP addresses to your phone, your laptop, your smart TV so they don't all start fighting with each other. It's even prioritizing traffic, making sure your Zoom call gets priority over a big file downloading in the background.
Okay, stop before we go one step further. This is the single most important thing you need to do. Step 0. Log into your router and change the default password. Right now. I'm serious. Those default passwords are all published online for anyone to see. Leaving it as is literally like leaving your front door wide open with a neon sign that says, "Come on in."
After that critical first step, the basic setup for a secure network is a pretty simple 4-part process. You give your network a unique name, that's the SSID. You pick a wireless channel to try and avoid interference from your neighbor's Wi-Fi. You choose WPA2 Personal for security, and then you lock it all down with a really strong passphrase.
Now remember I mentioned those background tasks? Let's talk about one called NAT. This process is the unsung hero of your home network, for sure. See, your internet provider only gives you one public IP address for the whole house. But you might have, 10, 20 devices that all need to get online? NAT is the magic that lets all of those devices share that one single address. Think of it like a big apartment building with only one mailbox out front. NAT is the friendly doorman who makes sure every piece of mail gets to the right apartment.
So sometimes you actually need to let traffic from the internet in, for something like online gaming or a home server. Port forwarding is one way to do this, but it basically props a door open permanently to a specific device. Port triggering is way smarter. It only opens that door for a brief moment right after your device sends something out first. So what's the big takeaway here? Port triggering is way more secure because that door isn't just left hanging open 24/7.
Okay, so we've pretty much cracked the code on the home router. But now, let's completely shift gears. I want you to imagine you're not managing Wi-Fi for your house, but for an entire university or a giant corporate office. You can't just run around configuring hundreds of these little boxes one by one, right? The scale of the problem is just a completely different beast.
This is where the wireless LAN controller, or WLC, comes into play. It is the central brain for these massive networks. The individual access points you see on the ceiling, they become lightweight. They're kind of dumb, actually. They just get plugged in, they find the controller, and they download all their instructions. Every bit of configuration, management, and monitoring happens in one single place. It's a game changer.
And here's how that WLC keeps all the traffic organized. Think about the employee network and the guest network at a company. The WLC maps each of those Wi-Fi networks to its own separate virtual lane on the network using something called a VLAN. It's like creating invisible walls that ensure guest traffic can never ever cross over into the employee lane. This keeps everything secure, even though it's all flowing through the exact same hardware.
That security separation goes even deeper into how people actually connect. At home we use WPA2 Personal, one password that we share with family and friends. But in a big company, that's a security nightmare. Imagine if someone left the company,
You'd have to tell hundreds of people the new password. It's just not scalable. That's exactly why they use WPA2 Enterprise, which forces every single person to log in with their own unique username and password. So how does the network check all those individual logins? It uses another key player, a radius server. When you try to connect to the enterprise Wi-Fi, the network doesn't actually check your password itself. Instead, it passes your credentials over to the radius server, which acts as the ultimate bouncer, the final authority on who gets in and who doesn't.
And this radius server provides 3 critical services, known in the biz as AAA. First, authentication. It answers the question, are you really who you say you are? Then authorization. That answers, okay, now that you're in, what are you allowed to do? And finally, accounting, which answers, what did you do while you were here? This creates a clear trail of individual accountability, which is just absolutely essential for any business.
Okay, so whether you're at home with one router or in a massive building with hundreds of access points, let's be real, things can still go wrong. So for our final part, let's walk through a structured, logical process for fixing Wi-Fi problems, a true method for the madness. Instead of just randomly rebooting things and hoping for the best, professionals use a structured method like this one. The core idea is to move logically. You gather information. You form a specific theory about the cause, and then you test only that one theory. If you're right, you implement a fix, you double-check that it actually worked, and then you write down what you did. It's about being systematic, not about getting lucky.
So let's try it. The problem, you have zero connectivity. You can't get online at all. Where do you start? Well, your first theory should always be the simplest thing, the thing closest to you, your own device. Did I type the password wrong? Are my network drivers up to date? If all that stuff checks out, then you can move up the chain. Okay, is the access point even plugged in and turned on? See, it's just a methodical process of elimination.
Now, what about a slow network? This is where things get really interesting. One of the most surprising reasons for a slow network can be a single old device. You see, a Wi-Fi access point often has to slow itself down to communicate with the slowest device it's talking to. That's right, one old phone or an ancient laptop can literally act like an anchor, dragging down the Wi-Fi performance for everyone else connected to that same AP. Crazy, right?
So to fight back against slowness, it really helps to understand the 2 main Wi-Fi highways available, the 2.4 and 5 GHz bands. You can think of 2.4 GHz as the old, crowded 2-lane country road. It goes a long way, but it gets a lot of traffic and interference from things like microwaves and cordless phones. 5 GHz, on the other hand, is the modern, multi-lane superhighway. It's way faster, much less congested, but its signal doesn't travel quite as far.
So here's a fantastic strategy to boost your speeds. You essentially create separate on-ramps for those 2 highways. Give each band its own distinct network name. Then connect your new, speed-hungry devices, your gaming console, your streaming TV, to the 5 GHz superhighway, and move your older devices, or simple things like smart plugs, onto that 2.4 GHz country road. This gets the slowpokes out of the fast lane and lets your important devices absolutely fly.
And one last, absolutely critical piece of advice that applies to everything we have talked about, from your home router to a giant well C. Always keep the firmware on your network devices updated. These updates aren't just for fancy new features. They patch major security holes, they fix annoying bugs, and very often they deliver huge performance improvements. It is the golden rule of a happy, healthy network.
So, to wrap it all up, your little home router is a surprisingly powerful all-in-one device. Big enterprise Wi-Fi depends on a central brain and individual logins to stay secure and manageable. And no matter the size, having a systematic approach is the absolute key to fixing any problem that comes your way. You see, making wireless networks reliable and secure, it isn't magic. It's about deliberate configuration and smart choices. So the next time you connect to a guest network or you split your home devices between 2.4 and 5 GHz, you'll actually know the engineering and the security principles that are working behind the scenes. So my question to you is, how does seeing the structure inside this invisible world change the way you use it every day?